Okay, so we'll start by going over homework 5, and then we'll get into some more newish content. All right, so was this the only window he gave me? Okay. So you're given an IP address for a box. Let me pull up the assignment on my other screen here. You're given an assignment for a box, and you're essentially told that you have to find the vulnerabilities in it and patch them, right? While I get this set up, let me just SSH in. So the credentials that were given by default were I can use Firefox.
Yes.
No restrictions. Okay.
Yeah. I don't know.
Yeah, don't open your email. Okay. Let me pull this up and go to homework 5. So we're given that there's a server running on this IP address. Log in using Debian. All other accounts on the system have ABC123 as their password. That should give some red flags. All services on the system use the default credentials for the given service. It's a web server, and we want to patch polls and keep web and SSH access available. Okay, so let's just first SSH in. So it's 10.x.10.43. Are you on the VPN?
Yes.
Did it?
Yes.
Why is it hanging?
It's hanging.
Oh, it is because it's on Windows. Okay.
Such a hater.
Okay, so something just happened. Anyone want to point out what it was? Because we did get a few questions about it. I just logged in, and something abnormal happened.
No password.
No password. All right, let's take note of that, right? Before we get to resolving that or looking into why that might be, let's first just enumerate the system, right? Find out what services are running. So I'm going to run ss-plnt-u so I can see all the UDP and TCP ports. Okay, something is on 4444, not suspicious at all. Port 80, port 22, port 9001, and port 9000. From the top of our head, we know what 80 and 22 are. 80 should be HTTP, 22 should be SSH, and we see these mysterious ones over here, 9000, 9001, and 4444. We haven't run this command as sudo, which means that we can't see the processes column. Let's run it with sudo so we can get some more information. Okay, we see nginx is running, SSH is running. Those are the normal ones we expected. REST-FS on those higher number of ports, and then netcat on 4444. So again, more alarms going off in our head regarding that. Let's try to get to the bottom of what could be causing netcat. So we can run psaux grep netcat and see what's going on here. And wow, okay. We see that I'm gonna zoom out a little. Actually, let me less it into -s. That was a mistake. I'm gonna redo that. Okay, we see that there is something running on port 4444. Seemingly, it's a root process because it is running a netcat listener. I guess it doesn't necessarily need to be root, actually. But we see that there's a netcat listener running on these ports. So a few things that we want to do. First of all, let's figure out what's causing this to even be running. Was this all supposed to show up? Oh, okay, no,
yeah. That's a leftover. Ignore the above.
Okay, sure. I'm just gonna grep it into here again. And we see that there's a process ID for all of these, right? Like 484. We can run the ptrace command, I believe. That's the correct command to find out what could be causing it. Oh, I guess that didn't work. Pstrace, pstree 484, nc. Okay, well that didn't give us very much information. Well, there's a few kind of methods that we can take here. Okay, well, thank you for that. Pointed it out. So I just ran pstree, and now we can see that this netcat script is being run first by sh, which is just the command, like it's a shell command that runs the script. Flock, which is doing process management to make sure there can only be one of those programs open. And at the root, it's being run by cron. So pstree will show the parents of a certain process to show what could be spawning that process. when we first see that netcat listener, we could just kill it entirely. Like we have the PID, we can totally run just kill-9, kill-9 on the PID number, and that will get rid of it. But we want to find out what the source of this listener is, because something had to have caused it. And we see here that it was caused by cron. So let's look at our own cron tab. Just run cron tab -l. Nothing there. Our user doesn't have anything. So we can go ahead and like look through all of the users to find their cron tabs, or we should do that, but we should also look at the root user cron tab. So sudo cron tab -l, and we can see at the bottom this flock command is running Mogus. So let's go ahead and edit the cron tab. I did not want this editor. Whatever. Gonna remove this. Is there a simple?
It's not Vim.
Yeah, it's not Vim. Okay, well, I'll just do it manually. I'm sure there was a shortcut that I just didn't know. I'm going to hit Control N or Control X and Y to save, and enter. And now if I do Ctrl-L, it's gone. Okay, well, so that means that this process won't keep running again, but it is currently running. So if I again do ps-aux, grep netcat, we still see it running. So let's do sudo kill all -9 netcat, because all of these are that like suspicious traffic. And now if we try looking, it's all gone. All we see is that grep command that we just ran. So we're all good. Okay, so that was the first part. We just got rid of that. Go ahead.
We should also eject Mogus on the system.
Yes, let's delete the file there, because if we look at how this was running, we see that what it's doing is it's echoing a script and storing it into this Mogus file, and then it's turning it into an executable and running it. So this Mogus is still on the system. If I do ls user /bin /Mogus, we can see it's still there. So let's remove that. I'll sudo remove it because it's in a root user directory, and now it's gone. And so now it should not be able to be restarted, even if somebody tries to run that command again.
So emphasis, it's the three, you have to do 5 separate things to get rid of it. If you just kill the process, it's going to respawn. If you delete the file, it's also going to respawn, because what cron is doing is it creates a file and then runs it. So you have to hit all 3 steps to properly clean it out of your system.
Yeah, and to be more specific, are you in Tmux? No? Okay, whatever. So the cron tab that was being run, it ran the script once every 8 hours, which maybe was a bit too sneaky to set up, but like essentially if you killed it, and it wouldn't come back again for 8 hours, so you would kind of be fooled into thinking that it was gone. So yeah. Okay, that's one thing. So we can now look at our ports that are running. We see now it's just these ones, and again, let me run it with sudo to see what's actually running. Nginx, SSH, rustfs. We don't necessarily know what rustfs is. We can totally Google that, and that would be a good thing to do. And you'll find out that it's like an object storing server similar to Amazon S3, AWS S3. So it's just storing files. And we should now get into the stage of looking into the config files to see what's going on for each of these services. Before that, actually, because I did mention this at the start, we noticed that there are all, we're given the passwords for a lot of these accounts. User Debian has the password Debian. All other accounts have the password ABC123. So the best thing to do once you see that is change all the passwords to something that, and write down the password. So change it to something more secure and write down what you're changing it to. You would do that just using the sudo passwd command, or I'll just run it. If I want to just change my own user account, just type sudo, just type passwd, and then I can change my own password. I won't do that, but a good amount of complexity would be either like 12 characters, including special characters. Even better would be to have a string of words as your password. I think we've talked about the Bitwarden password generator.
You've probably seen a lot of the passwords we've given you is 3 words separated by dashes, right? The passphrase.
Yeah,
they're generated with Bitwarden.
So a lot of people did use this, and I was pretty happy to see that. They were using this in order to generate passwords for the challenges. Passwords that are in this format have a lot more entropy because they're very long, so it's hard to crack. And even if you're thinking about it word by word, like the word bank it's using still probably has at least 2,000 words in it. So 2,000 to the power of 5 is what you're essentially looking at in terms of how much entropy there is, which is very good. So better than just having like 8 strong characters, whatever that might mean. So yeah, run passwd. If you want to change another user's password, then you do sudo passwd and then type their username. For example, let's run getInt group sudo to see what other sudo users are on the system. We can see there's Kyle, there's Earl, and there's Jordan. So we can change their passwords by running sudo passwd Kyle. And once you've changed the sudo user passwords, that counts as another point. So, okay, let's now look more into the services. So we saw, again, there's Nginx, SSH, and RustFS. Let's look at SSH first, because that's generally the most familiar to us since we use that pretty often. I'm going to open up the, I'm going to open up the SSH config directory. So let me see into it. Let's see what's inside here. We can see there's a lot of files here. If you just Google where is SSH config, most likely you'll get pointed to sshd_config. So let's look at that. I'm going to sudo vim it. Okay, let's see what's uncommented here. We can see that we were taken directly to permit empty passwords, yes. We might want to disallow that. I'm going to change this to no. Permit root login is set to yes. Let's also change that to no so that nobody can log in as root directly. And let's see what else is here. Use PAM is yes. Okay, cool. X11 forwarding just allows you to do, I guess, like remote desktop kind of, which is fine. Print MOTD we don't really care about. That's just sending a banner at the top of every time you log in. Okay, the rest of it seems basically fine. There are some things that we can do in order to make things technically more secure. For example, you can set log level to something like verbose. This isn't one of those things that we would have scored, but it's just like good to do potentially. So that if you're a system administrator, you want your logs to be as thorough as possible. So setting the log level higher would be a good thing to do. That isn't something that we're scoring you on, but if you had that in your report, that is a good thing to have. Stuff like that. So you can go extra is what I'm trying to say. Let's save this config file. And then I will run sshd-t, sudo sshd-t. Yes, and it passed, which means that there's no egregious errors in our config file. So now if we run sudo systemctl restart sshd, it should boot back up without any problems. We can connect those two changes we made, which were both password related, to that issue we saw in the beginning, right? We saw at the beginning that we were able to log in without having to put in any password. It didn't even give us a prompt. Can I open them?
Yeah.
Let me try now logging in again as Debian at 10.3.10.43. Okay, now it prompts us for a password. But what were those two configs that we changed? Permit root login, that doesn't have anything to do with us, right? Because we're logging in as our own user account. And then permit empty passwords. So somehow, by changing permit empty passwords to no, we were able to get the password prompt to come back. How might these two be connected? Or do they sound connected in any way? Any thoughts? Go ahead.
Try an incorrect password.
Try an incorrect password. Okay. I'm going to type the letter A. Remember, I didn't change the password. The password was Debian. I'm just going to hit the letter A, and we're logged in. So we changed permit empty passwords to yes. And what that seemed to mean is that as long as the underlying authentication layer thought the password could be empty and succeed, it allows the authentication attempt to continue. And so when we had permit empty passwords set to yes, it seemed to be treating all of the user accounts, or at least Debian, because that's the one we tried, as having an empty password and allowed that connection to succeed. Now that we have it set to no, it's at least showing the password prompt because it is blocking empty passwords. But we can type in some other non-empty password and it will allow that connection to go through. So we may have fixed one bug because now we're able to at least get a password prompt, but this hasn't actually solved the authentication issue yet. We'll get to that in a moment. For the time being, let's go look through more of the services and then we can get back to that. Actually, no, let me do that right now. So whenever they have anything issues with authentication, the problem that you're looking at could either be caused by the service itself, which means that you would edit the config file for that service. So for example, sshd_config, or you would have to deal with PAM. PAM is the portable authentication modules, if I'm getting that acronym correctly, which means that, or it's the module in Linux that is used for handling how different applications will authenticate user logins. We talked a bit about this in lecture, so let me go to cd into pam.d. I'll hit ls, and we can see all the different modules for the different programs running on this system. And we can see one in particular that sticks out because we're looking at SSH and but we're focusing on SSH. We can run the SSHD, or we can edit the SSHD config file, see what's going on there. So let me do sudo vim SSHD. And let's go from top to bottom and see what we find. Okay, first thing we see, enable maximum convenience, auth required pam_permit.so. I'm going to have this in the other window. Let me, I'm going to do man pam_permit. Any SO or shared object file, at least for PAM, will have a man page entry. So you can just type man pam_permit.so, and you should be able to find more information about what's going on there. So type man pam permit. It says PAM permit is the promiscuous module. It's a PAM module that always permits access. It does nothing else. What that means is the first thing that happens when you log into SSH is that PAM will redirect your request. It'll handle your request using this module. It'll handle your request using PAM permit.so. So it will always allow your connection to go through, which is a terrible thing, and which probably explains why you were able to type in any password and get in without any trouble. So I'm going to comment this line out because enabling maximum convenience is not a good thing. In fact, we might as well just delete this entire line. I'll keep it in. I'll delete it actually. Why not? For safety, you might just want to comment it if you're just testing, so that you can add it back in if you realize you actually need it. But I know that I don't need this, so I'm just going to delete it. The standard Unix authentication is handled through common auth, and it seems to have been commented out incorrectly. So I will add that back in. I'm going to save this for now, and then I'm going to look at common auth to see what's going on here. Common auth is the authentication settings common to all services. So it seems to rely on PAM Unix. It seems to rely on PAM Unix. So again, we can check the man page for that to see if this is something suspicious. And it's the modules for traditional password authentication. It uses standard calls, handles using etc shadow file for like password hashes. Okay, it seems to be fine. This seems to be not suspicious. We can just take this as what it's supposed to be. And in fact, the rest of the file has not been modified whatsoever. Seems we may be getting projector back soon. Let me check if OBS is still running. We're good?
Yeah.
Okay. So the PAM Unix seems to be fine, and we can even go ahead and say that the rest of this file is actually totally fine. The success equals 1, we kind of talked about this. So if PAM Unix succeeds, then it will skip the PAM deny and it'll go to PAM permit. So essentially, it's just allowing connections to succeed as long as the password authentication went through. So this file looks fine. If it fails, then it'll go to deny. It won't go to permit. So that's good. So now we can be pretty confident that the rest of the SSH file is fine. We can run PAM tester as we talked about to kind of confirm that the SSH settings that we have set for PAM are good. Something I'll just take for granted for now. But feel free to do that, and I think that would be a good idea, just to make sure you don't lock yourself out. Now I'm going to SSH in. I'm going to type the letter A again. I'll hit enter, and we should expect to be denied. Okay, permission denied. Now let me type Debian, which was our password, and that worked. So now we're all good. Any questions about that? We've now fixed SSH authentication.
I just would really like to comment that you can just SSH the root in the default configuration by just having SSH root.
Yes, yes. You could log in as any user because permit login was set to yes, and empty passwords was set to yes, and SSH was allowing SSH was passing all logins because of the PAM configuration. And so you were able to just do SSH root at your server, and you could SSH in as root directly. You wouldn't have to deal with any pseudo permissions or anything. You could just SSH in as root, which should not be the way it is. But now we've solved basically all of those, and by changing passwords, we would go one step further. And so again, that's something that you should do. Other questions about that? Are we fine on time?
Yeah.
Okay.
Go ahead.
Okay. You changed. Wait, so you didn't know what passwords to change, so you locked the accounts?
The users, not the main.
Yeah, that would be as long as you explained it, that is okay. Again, it's like if you're writing a report for someone who's asked you.
They're significant to the user or not because they have root privilege and they
Right.
do not privilege. And I just didn't know what other password to put, whether that is strong or not.
Yes.
I just decided to lock them from being root.
Okay. Yeah, that would be considered valid for this assignment. If we for example, we or like the home lab operator who is technically giving this assignment could have included the user accounts that they want to keep on the system. So they could have specified that, hey, Kyle, Earl, Jordan, they're all not suspicious. Keep them as pseudo users. But since that wasn't stated, if you remove them as pseudo users and explained why you did that, then that's all right.
Yeah, because the only thing that was said there is like to keep it as secure or something.
Right.
So it wasn't saying about other people having access to it. Plus, if I'm going to be changing the passwords for the users, am I going to be changing it based on my preference? Or did you choose your password? Because if I change your password, you cannot log in too.
So if everything's in the report, so you could like hypothetically change your passwords and put the new passwords in the report, and the home lab operator reading this report will be like, oh, okay, the password for Kyle has been changed to so and so I'll log in using that. As long as it's in the report, you're giving them the instructions to log in with the more secure system.
I see.
Yeah, so that'll be fine. But if you did, like, I'm guessing you set it to no log on or something like that to lock them out.
At first, like, there was an option where you could just do like lock their password. I think. Like,
Pass WD-L.
Yes.
Oh, okay, yeah.
And I think that like prevents you from having that completely.
Yeah.
There was one more where first is you make it reject the password on the SSH. The other one is to just completely ignore it.
Yeah.
Yeah,
that would work. Again, it's like one of those things where it's kind of up to you what to do. So as long as you explain it, you're all good.
And then I logged myself out.
Yeah, that one happened to a few people. We can talk more about that later.
I logged myself from sudo, not from the active.
Okay, that's different.
The other one, I still get access to the depth, but then when I was doing the no option to all, I forgot to take out the column.
Yeah.
And because that exists there, I just.
Oh, it broke. Okay.
I just broke the whole thing.
I see. Okay.
I would like to point out that you can run a piece on it. You can get yourself access again. Like 30 minutes before the assignment is due, then I was just more worried about having the correct formats for the assignment.
All right, let's continue. Unless there's other comments, but so we've secured SSH now, and I'll just run this again for to have it up again. We know SSH is on there. Let's look at Nginx now, which was on HTTP. So again, this is one of the things you can Google. Just find out where the Nginx config is. So you would cd into etc/. Nginx is structured so that there is a main config file in nginx.conf. So we can look at that. And it is including all of these files from the sites-enabled directory. So Nginx can host multiple websites at once, and it can reverse proxy between them. So everything that is hosted in the sites-enabled, everything that is hosted is in the sites-enabled directory. So we can ls sites-enabled. And okay, it's highlighted in blue, which means that it's a symlink, so I can do read link, nl sites-enabled, nl fan club. And it gives us two sites available. So this is just how Nginx structures its websites. So all of the websites are stored in sites available, and if you want to enable it, then you symlink it into sites enabled. Did I say that correctly? It's in sites available, and then you symlink it into sites enabled to enable it.
Read the documentation.
So let's go into sites available.
The point of reverse proxy means you can actually host multiple websites on one web server, and then you can just direct them to differently with like different host names, right? So I don't know, cs.ucdavis.edu, ece.ucdavis.edu. You can host them on the same server, but the sites enabled trait allows you to say, based on whatever host name we're receiving from request, serve this different HTML file. That roughly.
Yes, that's about it.
Was the shell file on the website also?
We'll talk about that. But first we're just looking at Nginx, so let's see what it's doing. So it's listening on port 80, as we know. The root directory for this website, which is where all the HTML content is an opt.nl fan club /site. Let's look at what this website even looks like. So I'm going to browse to it. This is always a good thing to do. Find out what's on your website so that you know what it looks like. You know what it shouldn't look like, in case it ever gets broken. So it's just photos of the Twitch streamer Northern Lion and company. Okay, so Boston Lion. So it's hosting index.html. It's index. It has an error page. What I'm doing right now is just going line by line to look at what looks suspicious, and then basically scrutinizing everything. Okay, the root directory will lead to 404 if it doesn't find the files. There's this DAV thing, which we can consider whether this is even necessary. So this is something to Google, look through documentation and find out what it is. And if you do, you'll find out that these two methods here are allowing anyone to read and write by using these methods over this protocol called WebDAV. So it allows anyone to put content onto the page, onto the website. It allows anyone to delete HTML files. It allows anyone to copy or move files just by sending web requests. And so these two lines are very much a vulnerability, and we should just comment them out right away.
I tested one of them, it failed for me, but I just commented anyway.
Well, the script that we're running does test them, and it was successful. So it depends on how you format it. Some of them are formatted a little bit.
I tried some of the formats I found, but it was failing still. So
I can send the command that will work if you'd like to try it, but assuming the boxes are still up, which I think they are.
They are.
Anyway, we see that there's this images thing, which is passing from port 9000. So any requests that are sent to images will be proxied over to port 9000, which we did see is running on the system. It was RESTfs. And then it's just doing setting some settings for what gets proxied, so what gets set into headers, and whether errors are intercepted, which means that if a 404 hits, will this website deliver its own 404, or will it deliver port 9000's 404? Anyway, we do see the /images directory, and if we open one of these images in a new tab, we can see that it is in fact on this /images directory, and we can test out that 404 thing. Let me just type random text, hit enter, and it's being intercepted by the website, so it's delivering its own 404. Okay, and then we see this over here. So what this says is if you have files anywhere that follow the format of .php, then run them using the fastcgi, or run them using the PHP 8.2 socket. So we're essentially running arbitrary PHP code. If there's any PHP code running on this website, then it gets run. This isn't necessarily a bad thing if your website is running PHP, but we should kind of investigate to see if this website is running on PHP or if it doesn't rely on it at all. Because as we saw over here, anybody is able to put any kinds of files onto the system. So they could very well use these WebDAV methods in order to put in a web shell, and then these lines at the bottom will cause that web shell to actually be run. Yes.
What I did is I took them off and I checked the website and the issues after that.
Okay.
Is that like does it this way or not?
You took the lines out, or you took the files out?
I commented the thing, copied the file to a different name and took them out.
You could do that, because if you commented out the lines, then it won't run anymore. So if you just change the file name, then it would still run under that new file name. So
I still commented the lines.
Yeah, so you're good.
Copied into a different name, so if it's like laid by there or something,
then it works. Yeah. So I've just cd'd into the directory that we know where all the HTML content is being hosted. Let me type ls, and we can see that this is everything that's on the system. We see the index.html, we see 404. There's some JavaScript, CSS, and there's shell.php. Okay, cool. So let's remove shell.php. This is like a slightly risky thing to do, but we could also just browse to it first to see what's going on. And oh wow, it's a web shell. And hey, it's all those files that I just saw. Great. I kind of wonder if you could just remove shell.php from here. Well, that works. You close the door behind you. Kind of. There is a more thorough way to do this. So if you've done this, then you remove the shell, so you're good. You've done step 1 at least, at the very least. Let me cd into the directory above, and we see that this website is being hosted via MakeDocs. If I'm pronouncing that correctly, it also says it at the bottom of every page. And so we can. Oh, it could be Markdown.
Okay, let's.
Whatever. Debate for later. So I'm going to. You could definitely look into how whatever this is called, whatever MKDocs works. But essentially, if you ls into the docs folder, you can find all of the content that's being hosted on this website. And if you run sudo make docs build, then you'll rebuild the website. So I'm just doing this right now. And now let's see if the shell is back. Because we just rebuilt based on everything that was in the docs folder, and we saw index is in there, shell is in there. So let me go back to the shell. I'll reload. Oh, hey, it's there. Okay, Okay, cool. And then let me go into the docs folder and remove that shell. Did I remove it? I might have had to sudo it. Yeah, sudo remove shell.php. I'm gonna type ls. Now it's gone. I'm gonna do sudo make docs build, and now it should be gone forever. So if you remove the shell.php file, then that is enough to just remove the vulnerability entirely. So that means that nobody will be able to bring it back. But because it was also in the docs folder somehow, if the website administrators like change the web content and then rebuild, then it means that it'll come back. The shell will come back. So we'd have to also delete it from there just to be absolutely sure that that shell will not come back. But again, it was enough to at least remove it for the time being, to just remove it from the sites folder. Any questions about that? So 2 vulnerabilities for Nginx. One was the PHP, and one was the web. Yeah. So let me go back into the Nginx folder. So all that we found out from this is that the website is hosting static HTML content, right? It was index.html, 404.html. It doesn't seem to have any PHP. And you can certainly run like a grep or a find command in order to confirm that there are no actual PHP files here. So I'm going to go ahead and go into sites available and remove or comment out these lines here, just to make sure that their PHP files will not be run. Oh, wait, actually, sudo t%. Let me confirm.
What the heck?
Okay.
Which crap?
If you aren't a sudo user and you need to edit a write protected file, you can do !sudo t%, and it'll run sudo and paste all of the content from here into the same file. So it tees it into what you already have. Anyway, now let's run sudo nginx-t to see if the web content is good and it says the configuration file is okay. So now we can safely run sudo systemctl restart nginx.
Remember that changes to config don't take effect until you restart the service.
For most services, PAM is an exception because it's just a module, and so I don't think it's being run by systemctl. But what Jason said is entirely true for like anything that's being run by systemctl essentially. So like nginx, SSH, and restfs, which we will now take a look at. So again, you can Google where the restfs config files are. Let's browse through those 2 ports that we saw, 9000 and 9001. Okay, 9000 says access denied. 9001, what will it say? Wow, there's a nice login portal brought to you by Rust, I guess. I'm going to double check the recordings because I'm paranoid. Okay, now let's cd into the rustfs config directory. Rustfs is kind of unique in that it doesn't have its own dedicated config directory. It just keeps all of its environment variables in etc default. So I'm going to look at what's going on here. So vim rustfs. Rustfs access key is rustfs admin. The secret key is rustfs admin. The doc that we received at the very beginning did in fact say that all of the services will have default credentials for those services. So this checks out. In fact, if we just log in using rustfs admin, we're allowed to log in. And these were just the default credentials. So we want to make sure that we're changing those. So let me do that. This is read only again. Let me sudo, so I don't have to type that weird command again. And then we can just change this into whatever secure password we want to. And not going to demo it, but you would want to change it into something more secure than what I've just typed in there. All right, should we turn off the Discord stream?
Yeah.
Okay, 1 moment.
Recording should still be fine because I just.
All right, we'll continue now. So you would want to change it to a secure password. I'm not going to use what I just typed, but that would be enough to make sure that unauthenticated logins, or that would be enough to make sure that the password is no longer default. You would have to run sudo systemctl restart restfs. Aside from that, there were some folks who were asking about, whether we can set this port to be localhost only. So whether these ports need to be accessible from the open internet, which is a good question to ask. So once you've changed the default password, you can be pretty sure that nobody will be able to log in and delete images. I'm logged in right now, aren't I? So there's this images bucket, and you can delete any image that you want to. I'm going to delete this one. Do not do this, but I will delete it just for demonstration. And now I'm gonna have to Control-Shift-R. Oh, there, look, this image is gone. It's been like replaced by this box. So you would not want to just delete random images, or you don't want anyone to be able to delete images, for example. So you want to set a good password for that login, make sure that nobody can delete images up to their own will. So that's one thing to do, changing the passwords. Another thing you can do is make sure that this port isn't even accessible to everyone. Because right now I'm not on this system, I'm just VPN'd in, and I'm able to access this port. If we want to, we can set it so that only localhost can access these two ports. So port 9000, we saw it just said access denied. That one is definitely like you do not need to have access to that. Port 9001 is an authentication endpoint, and you can make an argument either way. Like maybe you're an administrator who needs to be able to log into the RustFS console from a different machine. Then you might want to set this to local, or then you might not want to set this to localhost. Because if you need access from another machine, then only opening port 9001 on localhost will make it so that you can only access this port if you are specifically on the server that is running this. So if your web server had a graphical user interface, you could open up the web browser on that own web server, type in 127.0.0.1:9001, and then it would open up that same RustFS console. But if you are configuring it from another system, like I am doing right now, then if you set this as a config, when I reload the page, this will go away because it's no longer being hosted on the same website, or I'm no longer accessing it from the same server. Does that make sense? The difference between like localhost versus opening something up broadly. I'm going to just save this, and I'm going to run sudo systemctl restart rustfs. And now if I reload, it will not connect because Firefox cannot connect to this because the port is now only being hosted on localhost. And this raises into question, like now if I reload this page, will all the images go away? And the reason that they don't, other than that one image that I already deleted, is that it's that the way that Nginx is proxying these requests is that it's doing a connection locally. So Nginx handles your request to the NL side image, and Nginx will itself contact RustFS, which is running on the same system, which means that it's contacting RustFS on localhost. Localhost connections are accepted. So the image is able to be retrieved by Nginx, which then passes it over to you. So this is a perfectly valid configuration setting to set if you would like to do that. This isn't something that we would require, but it's a good amount of defense because nobody needs access to RustFS necessarily.
I disabled everything besides the 22 and
22 and 80.
Yeah,
that would be totally fine. And this is something that you can also configure via the firewall as well. We basically hit everything. I can end here, or I can talk about firewalls. It's up to you.
I mean, firewalls is pretty much, you need the website to be accessible. You definitely need SSH to be accessible. RustFS in the back door, not necessarily so. Allow, deny.
So what you could end up doing is sudo iptables -a input -p tcp destination port 22 -j accept. This will allow SSH. Oh, right. I'd have to install iptables.
Or you could install UFW, uncomplicated firewall.
Yeah, you could use iptables, UFW, Some people I think use NF tables, which is my preferred firewall. So that's a cool one if you like config based stuff. Firewall CMD or Firewall D is another one that's pretty popular on Fedora systems. Debian by default, oddly enough, does not ship with the firewall, so you'd have to download whatever you want to use, and so it leaves it up to you. So the firewall rules that you would ideally set is allow SSH, allow HTTP. If you did the logging server, then you would allow whatever port that might be. So I think for syslog, for example, it's 514, if I'm not getting that wrong. So you'd want to allow that. And then you would also want to allow localhost connections. So you do iptables-i localhost-j accept, which means that I believe that's the correct flag at least. It means that localhost connections will be allowed so that Nginx can talk to RESTFS without any problems. And then once everything is good, and once you've confirmed everything is good, then you can do iptables-p input drop, which will drop all other incoming connections. Questions about that? Yes.
There are some packages to make it permanent.
Yes, you could use iptables save. So what he's talking about is that iptables by default does not save your config files, or it's not save your configurations. This is again a reason why I prefer something like NF tables, which does keep things in config files. But iptables is, in my opinion, a little bit simpler. You could use this package called iptables-save or iptables save, and that will run by systemctl, I believe. And so it saves, if you run a command, you can save your iptables configs to somewhere in /etc, and then iptables save will on boot up load those same config files. The reason why we suggest iptables for this specific assignment is that when you restart your machine, the rules go away. And so if somebody accidentally logged themselves out, which did happen as it happens, we could just restart their box and they would be back in. So it wouldn't kill anyone's progress. Whereas if you use something like NF tables, it opens up some risk, but it's everything is a trade-off. So there's a good reason to have a firewall that lasts on reboot. So yeah, I think that's about it. For logs, you could configure something like syslog, and that would be sufficient for the assignment. Yeah.
How often do you reboot a server state?
Not very often. It
Define the machines. We try not to reboot them.
No, I think in the real world, servers will not get restarted very often. So it doesn't come up very frequently, which is why I guess you could say that's not a huge deal. But whenever an update comes in, you have to restart your machine. So like a system update comes in, you have to restart the machine, and patches are important. So that's about as often. You restart your machines whenever you need to update them, essentially.
When you need to update, I guess, the Linux kernel. All other things you can keep running, but occasional kernel patches need to be restarted.
Okay, so I mean, the question was because of like the firewall thing that it's not available because wondering if like Facebook systems servers or like websites often.
Yeah, it doesn't happen very frequently. So it wouldn't make a huge difference, but because you need to keep service uptime, it's just restarting kind of hampers with that. We don't do it too often. Yeah.
We're a bit limited on time, so I'll have to speed run these slides, or I won't cover as much. But I will be posting these slides in full. And all right, let's talk about Windows Active Directory. What the heck is an Active Directory? Because you've probably heard the term thrown around. The school probably also heard like Kerberos, authentication, CAS, whatnot. What is the whole deal going on here? So let me present you the problem that's trying to be solved. So we saw with Windows, you had these things called security policies, right? You go on, you click through the menu, you set the rules. That's cool. That's fine for one computer. But what happens if you have more computers? In like a small office, when maybe say like a really, really small business, like, I don't know, dentist office is the one I like to throw out, or at home or whatever. You have laptops, you maybe configure security policies, but there's just not that many people using computers that you can afford to run around and like maybe, let me just, here's a script, here's a file with all the security policy rules, let me just deploy it, and it's not going to be too much work for me to walk around everyone's computer. Also, it's not enough people working there that everyone can get their own computer, have their own accounts. We're not really worrying about, person A has to log into person C's computer, or B has to log into person D's computer or whatnot. So you can manage it with like 1 or 2 people just doing everything by hand. Problem is most businesses are not uh, 1 to 5 computers. This is just a random network I threw up in packet tracer. That's a lot of computers. Or especially when you get into kind of this quote standard corporate network. Oh, here's a bunch of networks. They have computers. You have servers running stuff, printers, Linux computers. There's a lot of computers. Every employee in a computer, or sorry, every employee in a company needs to have a computer, and then you have servers, and then you have microservices. It's ultimately the point is there's more computers than any even reasonably small team of like 10 to 20 people can manage. So what needs to happen is there needs to be some form of central control. Also with the thing of sharing computers. I want to be able to walk around building. I mean, hell, think of it like the CSIF computer labs. There are, a couple hundred students maybe at a time enrolled in CS classes. I want to be able to log into every single one of those computers, just in case. But the IT department has better things to be doing with their time than going to the CSIF computers and setting up 900 different user accounts and loading your passwords in and whatnot. So the idea is, what if we just put all the user information, the logins, maybe the permissions, whatnot, what if we put it all into one place? And then every time you wanted to log into like a different computer, you could tell this computer, hey, talk to this server to handle authentication. And that ends up being really scalable. Instead of like having every time you get a new computer, you have to load up a billion accounts and a billion settings on it. You say, grab all the security rules I need from that server, and then you'll just be configured in about 5 minutes as opposed to 500 hours. So this is, so enter Microsoft Active Directory. It's impossible to talk about Windows without talking about Active Directory because pretty much every big business running Windows servers relies on Active Directory to do administration. At its core, it stores, quote, objects. What are these objects? User accounts. Computer objects. Yes, surprisingly, computers, every individual computer is an object in Active Directory. And of course, groups you want to put users and computers into. Then it sets kind of policies. These policies is how do users and groups interact with computers? Who can log in at what time? Do you have permissions to share files, share printers, whatnot? And also defines how computers interact with each other. So, can the server use this kind of cryptographic key? It's just a whole bunch of rules that are centralized into one database. So Active Directory, you've probably heard these words thrown around as well. The main kind of overarching container in Active Directory is what's called a domain. Domain has a name, like ucdavis.edu, but it doesn't necessarily have to map to something on the internet. It just says this domain name, all of the computers that I manage will share this domain name. And then in that domain, all that information about the users, groups, and policies is going to be put in a database that sits on a computer called the domain controller. And then eventually, everyone queries the domain controller for any information. So kind of quirks I want to just briefly talk about regarding Active Directory. There's one thing is you can have accounts can share names. When a computer says, oh, I'd rather pull user accounts from a different computer, it doesn't necessarily get rid of the accounts sitting on that computer as is. So I can have an administrator account on a computer. So say, I don't know, say I have an account named Jason already set up on my computer. And then I connect it to Active Directory and say, pull all the users from UC Davis. There may be a JSON user in Active Directory, but that user is technically very much distinct from the JSON user I have on my computer. And then the way you tell them apart is the way you sign in is you add a little bit of text at the beginning. So now Windows Active Directory, or sorry, Microsoft Active Directory implies, it definitely works with Windows. The funny thing is, Active Directory, you can actually connect Linux servers onto it. You can use Windows accounts on Linux computers. In fact, that's how the CSIF works. All your accounts are in a Windows server somewhere, maybe on campus, maybe off campus. I don't know where it is. And they're pulling that information into the CSIF computers, which are, running Ubuntu. And then they're able to say, oh, I have a password that I use for everything, logging into Canvas, whatnot. Can I try it to log into CSIF? And that stuff will work. The way it does this is this thing called LDAP. LDAP, Lightweight Directory Access Protocol. Oh, sorry.
Is the server software that manages all these Windows only, or does it also exist on Linux?
Let's see. How do I want to explain this? So Active Directory, specifically Active Directory itself, is a Microsoft product and can only run on Microsoft servers. There are open source implementations of Active Directory that exist. I don't want to say they're not as good because I haven't tried them before, but most people, when you're a big business handling like $1 billion, you'd rather go with something so the world, for better or for worse, runs on Windows Active Directory, including the school. Mm-hmm.
So is that a single point of failure?
Maybe. It could be. The way you set up domain controllers, usually you have a normal domain controller, you have a backup one. But yeah, if someone gets into your domain controller, you are in big trouble, which is, the reason why it's some of the most protected, most restricted servers in a network. Think of it like, databases. I don't. It's people. Yes, it is very, very bad if someone gets into it. So that's why you tend to put the most protections as possible onto it. So it is like a trade-off risk that you play. Okay, LDAP. LDAP is the best way I would describe it is like SQL, or as one of our esteemed instructors likes to say, it's squeal. See, it just LDAP is just say, oh, this is a database. This is how users and objects are put in it. Oh, you can also ask it for objects in this way. Similar how SQL, it says, oh, data is going to be listed in rows and columns, and you can ask for objects using, select statements and whatnot. You use LDAP. LDAP itself is open source. Active Directory, the product, is just an implementation of LDAP. So there are products that I can, I do not hot link this, unfortunately, but I guess there are plenty of products that support this LDAP protocol, but are not necessarily Active Directory. But the thing is, Active Directory comes with a lot more bells and whistles that may be good for security, including works with Windows, which is a big deal breaker. Sorry, Linux users. Okay. The funny thing with hold up, see where I was. Okay. Also, a really funny quirk about Active Directory is any user that has an account in Active Directory can read the entire database. It's not called Active Secure Database. It's called Active Directory. It's supposed to be a listing of all the information. So theoretically, I could log into the UC Davis domain controller and read all the directory information. IT would get really mad at me if I tried to query it for stuff like that. But it is a very interesting quirk that it's very open. And of course, it leads to this kind of idea called bind user. So say I want to, let's say, oh, I'm building, I don't know, give a useful idea for something that Aggie Works would do. Some useful app for students that requires them to log in. New transcript printing service, or I don't know, schedule builder, but actually good, but actually looks good. Say I want to build schedule builder, but actually looks good, and I want to communicate with the school Active Directory database. Well, I would use LDAP to do it, and I would need something called a bind user to be able to talk to the school servers. I'll explain in a quick bit. So actually, here's a bit of a diagram. See if I can point to these. So say the application is actually good schedule builder, and you wanted to log in using your school account. So what would happen is the application I wrote would make a request to, let's see, when I tried to log into the website would send a request to the backend, and then the backend would forward that. Okay, the diagram is not, the labels are not great, but this is the best I could find that shows the process. I'd be able to, first I point my application at, hey, I want to get authentication information from this domain controller server. Then once it does, it says, okay, let me talk to the domain controller, look up a user, and then I give it the password. Once it has the password, it'll do a lookup, check if it's valid. If it's valid, it'll return, hey, you're able to log in. So in a way, you're able to delegate, kind of delegate authentication to this domain controller. A couple quirks about LDAP. LDAP, when you write an application to do authentication, the normal way of thinking things is, okay, I have a user and a password, and I want to check if they work to that server. What if I just sent that user and password to that server, and then if the server says, hey, that's a real user, return, skip a step, right? It's currently the way it's supposed to work is for my application, I need to create a user that's like web application user and use that to talk to the server, and then the server, and then afterwards I have to say, give it user credentials, check if user credentials are good. Why is it convoluted? Well, couple of system design reasons. If I was able to just say nonstop send a bunch of requests to users, say, oh, here's every single possible username that might exist. Try them against the server and see what kind of error codes it returns. That's an easy way to do reconnaissance. Other way is just kind of permissions. Web server may be only allowed to look at certain users and not look at every single user that's in the domain controller. Bit convoluted, but these are all system design questions. Also, you might have heard the word Kerberos being thrown around. LDAP is not Kerberos. Kerberos is just a way, kind of a encryption layer that is used to handle this kind of response. Because normally LDAP, when you send a request, it's in the plain text. So if I just set up a Wi-Fi router and say, hey, let me look at your edu roam or your CAS credentials, you can snipe it. But with Kerberos, it provides a layer of encryption. Is anyone in here in 153? Okay, a couple. I'll briefly. I'm not going to touch upon Kerberos. I will refer you to Matt Bishop's slides on. Let's see. If you want to talk about Kerberos, I think it's these slides. Shill ECS153. All right. Okay, how are we doing? Any questions about any of the stuff I've thrown around? I guess the core takeaway is you can delegate authentication to Active Directory. It works really well with Windows, which everyone uses, and pretty well with Linux.
Can we spoof the LDAQ response?
Yes. The point of Kerberos is that Kerberos, if you look at the protocol, there's a timestamp associated. So if you're not fast enough within the timestamp, it will kick it out.
So you can spoof it if you're fast.
Yes, theoretically you could. All right. Any more questions?
Can you use Active Directory on your Mac?
I have not looked into it.
Yes, it is.
It does, Apple does allow you to integrate Active Directory into Mac, it can be the Active Directory server. It is interesting set up on Macs, yes.
So cursed.
You can say I'll add to it.
For what use case though? Why would you need to sign in using, or actually,
Or Smart Fridge, of course.
see. You don't necessarily need to connect it to Active Directory. You can just say, well, actually, no, it does work on Android. Why is that? Think about every time you connect to edu roam. You're sending credentials that are eventually relayed to the domain controller somewhere on campus. So in a way it is, you can't directly be like, oh, join the domain controller, join the domain and get a bunch of Windows security policies because it's not running Windows. But the point of LDAP authentication is you can apply this information that's stored in Active Directory and then send it to any application that you kind of need. Can I make it a little more clear? All right. Let's talk about the fun part, the hacking part. I said it's hard to separate Windows from Active Directory, so anytime you look at how do I pen test Windows, inevitably the conversation will be how do I attack Active Directory. So it's kind of a work your way up. Before in Linux, you get in, you do some kind of funny escalation, you become root. For Active Directory, it's you get into a user and then somehow become domain admin, which is pretty much root for your entire domain. Very interestingly, because of how Active Directory works, you don't need to crack a password to get into the system. You could actually just, as long as you have the hash, you don't even need to know what the password is that created the hash. You could just send a hash, and that is pretty much as good as password for authenticating to Active Directory. Because if you think about how password authentication works, you're not going to send the password in clear across the wire because that's how you get man-in-the-middle sniped. So you're going to encrypt the password and then send the hash over the wire to get authenticated. So if you have the hash and you send the hash over the wire, that's pretty much authenticating without having the password in the first place. Very interesting implication. So how do you get these passwords or mostly hashes? Well, you have a big database full of user information. Is there a way to dump that information so I can just grab and dig through and get all the funny credentials I need? Talk about it. So the main database file is called ntds.dit. Normally, the obvious solution is what if I just Control-C, Control-V that file and then just like open it up and dump all the files? Well, Microsoft, that's like the first thing Microsoft solved. You cannot, while your server is running, while your operating system is on, you can't exactly just be like, let me just Control-C, Control-V the file, because Microsoft will hit you with, oh, the file's in use, you can't modify it. But as always, there's a way around it. If you're a member of a group in Active Directory called backup operators, you can use funny tools to just clone the file anyway, even if it's in use. That's always funny. Another funnier trick is called DC sync. So, if you have a primary domain controller and a backup domain controller, naturally you want them to stay in sync, right? You make something on the primary controller, doesn't get past the backup controller, your data is out of sync, and then bad things end up happening. So they have to be able to talk to each other and synchronize information through a process called replication. So the bright minds at Red Teaming Offensive stuff incorporated said, what if, say, every time I talk to a domain controller, what if I pretend, hello, I am Windows domain controller, please hand me all of your user authentication information because I really need to synchronize my servers. So that's called DC sync. You synchronize self, pretend to be a domain controller of your own, and then you're just able to grab the data. Naturally, synchronizing this being such an easy attack, you have to have really high privileges in order to, be able to dump the user information like this. Thing is, this is kind of, but nice. So, this is an example of me running a DC sync attack. You pretty much just, you see all the users, you dump a bunch of hashes. You'll recognize that these are all the same. This is because this part of the hash is just like empty. This second half is what the actual password hash is. Fun stuff. But now it introduces the problem of the chicken and the egg, right? Oh, I want to grab the hashes to be able to become admin, but I need to have admin rights in order to grab the hashes in the first place. So what the hell do I do? So there are, as usual, similar with linps and all the Linux stuff, there are vulnerabilities in Active Directory that allow you to act as administrator without having to log into admin. So Kerberos, we talked about it. You might have, the way it works is you ask the domain controller for tickets, and then it hands out tickets. You get those tickets, and using those tickets, you're able to have other privileges. So the natural question is, can I spoof those tickets? Well, it's a little tough to spoof those tickets because they're encrypted. Certain parts of them are encrypted by the domain controller itself to say like this is a valid ticket and no one tampered with it. But the thing is, the thing they're using to encrypt it is in a user called KRBTGT. So if I broke into that account, I'd be able to forge any ticket I wanted because then it's encrypted the right way. It looks valid. So forge any ticket you want. How do you as is so password hash encrypts all of Kerberos tickets. You can generate any account if you have your hands on, and if you just go into users and computers and you click through the menu, you can just see the user and you can set whatever password you want. Okay. Okay, I know I ran through kind of the Active Directory hacking. The actual techniques are a bit. I cannot cover them in 10 minutes. So I would recommend, if you're interested in learning about Windows pen testing, talk to us afterward and we can drop some resources in the chat. Okay. Group policy. I'll just skip through this. Group policy, I was saying, Active Directory is really good at pushing out group policies to tens of hundreds of computers without going through it yourself. How do you do it? You go to domain controller, you create a policy, you say send it to everyone, and then it gets sent to everyone in the domain. Of course, as we saw on Thursday, you can set group policy without being part of a domain. You can set your own rules, but if you join a domain, those rules will override whatever you put on your own computer. Really funny, a really common slip up of Active Directory security is they put a lot of emphasis on users being in the right group and those groups having the right permissions. If you're not careful, don't configure it, people can come in with too many permissions, and then it opens you up to all of these funny attacks. Hacker recipes, I would recommend looking at those for all the different things you can try against Windows. And of course, firewalling. How do you firewall Windows Active Directory? These are the common ports that it runs. It all acts as a DNS server. You need that to work. Kerberos, that's part of Active Directory. LDAP, you need it to run. And for some reason, it always needs Samba to work. Why? Microsoft said so. So if you have a firewall, allow just those ones and probably block everything else. Okay. Any questions about Active Directory? I know I kind of blitzed through that, but any last minute questions?
So do you hack Windows with Windows, or do you hack Windows with something else?
There's a bunch of Kali tools that are already built for hacking Windows with Linux. Some seminars I've listened to do recommend like, you should try Windows with Windows to live off the land, so better disguise yourself. But that's kind of a more advanced technique. All the tools you need are already available on Kali. More questions before we go? All right. Do you want me to refresh the slides? Or?
Yeah, absolutely.
Okay. Tab in, tab out. All right, Ethan, do you want to come up? All right, do wrap it up. Yeah. Thank you all for taking ECS198F. I know we put you through a lot of homework, a lot of report writing, but we wanted you to provide an experience that we wanted to give everyone, which was do cybersecurity club training in a organized way that would get people that maybe didn't have time or the opportunity to do so to try and learn some of the things we do in our own club. We invite you to join us for competitions. All of the stuff you've done in classes put you pretty much like 80% of the way towards being a member of our team. So we have an open invite for you to come do our competitions.
So these two images are from some of our more previous competitions. So one on the left is from CPTC, that's our penetration testing competition. So that's things like assignments, 3, 4? That was the global final. So we went to Rochester, all the way in upstate New York in January. So it was snowing and stuff. And
the competition is literally identical to all the stuff we put you through.
Yeah.
Pen test, report, is based. All the pain is based on our own experiences.
Yeah.
How much time you guys were given for your competition?
8 hours.
This one was 2 days. So we had 8 hours one day and then 8 hours the next. Well, 12 hours the next day. Had to submit at midnight. So we were there. We were in the hotel room until midnight.
The normal competition rounds at Stanford is an 8-hour day, and then so 9 to 5, and then 5 to midnight is you write the report, and then you are graded exclusively on the report itself. So ring a bell.
We can and the one on the right is the Collegiate Cyber Defense Competition, CCDC. We went down to the regionals 3 days before the quarter started. And so that's photos from there where we placed third overall. Yeah. So that's defense style competition. So thinking more about assignment 5, technically assignment 6 if you want to consider that as well. Yeah, assignment 6 for sure actually. Here's a couple images.
Yeah. If the assignments, I trust you, the struggle in competition is just as much as the struggle in the competition. So
What did you say?
I don't know.
The struggle in the assignments is just as much.
We struggle in competition as well. So
Yeah.
I don't know if that's a reassuring thought of saying, yeah, the competition is going to be a jillion times worse, or we struggle as much as we do. But there's loads to learn. We've given you kind of a glimpse into our world of practical cybersecurity, and the rabbit hole goes very deep. So we invite you to join us in our jump into the well.
Can you give us some suggested challenges for us to try afterward?
Our homework assignments. So, yeah, we can give resources for sure, especially for CPTC, penetration testing competitions. Hack the Box is a great resource.
Yeah, like we have certain hack the box challenges that
We can.
So for over summer, we're going to start training for CPTC, so penetration testing competition. Is anyone here not in the CPTC channel but interested in coming to training and or participating in the competition?
If you're graduating, you can still join for the trainings, not for the competition, but for the trainings.
I'm graduating for.
Yeah.
Bro, no one wants to do competition. It's over. It's over. No. Yeah. If
I know what I have.
you're not no one.
Yeah, if you're still interested in continuing doing this, just drop us a note in Discord. We'll probably send forward announcements to the class channel anyway. So
Yeah, just let us know. That's all we have. Thank you again for being a wonderful class.
Thank you. Yeah, thank you everyone. Thank you. There is an evaluation. Okay, I have to log in. Cut the record. No. There is an evaluation form, end of quarter evaluation form in the Canvas. It just dropped. We would really appreciate your feedback, and there's a little extra stuff in there. We are interested in if you are interested in talking to us more about your experience in this class, there's a, hold up, let me just pull it up. This one.
So the form itself is anonymous.
This form itself is anonymous. If you are okay with us reaching out to you after the class, maybe over the summer or something, to talk about your experience in the class, because we want to use this information to improve the class, talk to the department to convince them to support us even more and maybe conduct research. Second Google form. This one's anonymous. The other one is not. So if you think we're evil and hate us, just fill out the end of quarter eval.
And there is a question on there, I believe, that asks if you would like to essentially help us teach this course for next year. So if there is enough interest in some of you guys teaching the course, then we'll send out another form, a non-anonymous form, so that we can collect names who might be interested in potentially being instructors for next year. All right, that's all.
Cool. Thank you, everyone. Happy hacking.
Assignment 6 is due on Friday.